Okay, I think we're officially ready to get started. With it being week one, there will be latecomers and people who don't know what they're doing, and that is fantastic. We are all in the same boat. So usually on day one, I show up my camera here. I don't know if it's working or not. Can you guys see me? It's not showing up in my corner. There I am. So this is my beautiful office. This is where I will be doing 7 of our 8 live sessions, and if you ever need to see me, I'm in the Warsaw down in the basement and back corner. So come see me, but I don't really like my picture on here while I work, so this is all you're going to see of me. Bye. Okay, so there, I'm gone. If you have questions, you can unmute yourself and start talking. You know, feel free to interrupt me at any point in time. That's the whole purpose of this. Or you see at the bottom, you should see a chat box. Feel free at any point in time to type in there. I try to monitor the chat box as we go through. So week one here, we're going to try to just get all of the information out of the way. If we get into some math, great. And if we don't, we don't. We'll kind of go from there. So you will see, hopefully, there is a spot where they show hands. You can see like a little hand. You should be able to raise your hand. First things first, I would like you, if you have watched the 4 videos I sent you, would you please raise your hand? And this is not me. I just want to know who has information and who doesn't have information. So all right, so we've got quite a few hands raised. I appreciate that. If you haven't watched those videos, they don't take all that long. I highly recommend it because it will give you a chance to actually see how this class is going to be run. And because this is our first time using Ivy Learn or Canvas, whatever you want to call it, you know, we're going to have some bumps. And if you find things that don't look right, let me know as soon as possible so we can fix them. So, all right, well, thank you for that. Let me know. And if you haven't watched them, I would recommend doing that after this session. So we're going to cover roughly 2 modules a week within the Ivy Learn system because this class is built right in a 16-week for a normal semester. So in 8 weeks, you're going to be doing twice as fast. Jessica, how do you unmute? Oh, maybe it won't let you because I muted you. There should be... all right, I'm going to unmute you all. So now I want you to all mute yourselves. Hit the button so you can mute. That way you will now, good job, everybody. So you guys now control your own mute. So you can unmute to have a question. But Samantha is active. Okay, so I'll mute her. One thing that on my side, I can see whether or not you are attentive or not. So I won't ask you questions, obviously, if you logged in and then go away. Yeah, Samantha, I can see you just weren't, you were inactive there for a minute. You're good. I don't count off for attendance. So if you log in and then never, you know, say anything, you know, you're good. Do your thing. I do record this session. I'm hoping I can figure out how to post the link to this later in case you really want to hear my voice some more. There it is. So we're going to just kind of go through. If I can, there we go. So this is kind of how these sessions are going to go. I'm going to have a basic outline of the goals of the session, and we'll talk through them. So like today, we're going to do a brief syllabus, calendar, web work, resources, modules, talk about practice exam, my expectations, and what we're doing this week. That's what we're going to get through. Most weeks, we will do some math. None of the math that we are going to do is located in your packet. There are videos to go with every page in the packet. So why should I go over those videos here, those questions here, when you can do those on your own? So any math that we do in these sessions, I call them Becky Specials because they're just special for this class. Okay, so let's go ahead and talk about this. Now, once again, this is the first time I'm using GoToTraining, so I don't know how great of a job I'm going to do. You'll all just get over it. So first things first, hopefully you guys have all been in the class. A lot of you have been in and done work, which I really appreciate it. So just to get started, if you haven't clicked on the syllabus tab and gone through the syllabus, I need you to do that today. Because if you have any questions about that, you need to make sure that you get those taken care of. So that was the first thing on the list, was the syllabus. Web work is where you do your homework. Some of you have already been in web work and been working in there, and that is fantastic, because to stay on pace, you really should have the first 4 sections done this week by Sunday. So if you haven't started, you might want to get going on that. One thing I want to point out in web work, you will see on the right side, these are again links to the videos that go with your packet. So there are multiple spots to get those videos, and one of them is within web work. Another one is within the modules. I think it's under learning activities in the modules. This hippocampus, that leads you to the videos. Or I think I did send you a Excel spreadsheet that has all the videos in it. That is, again, another way to get those videos. Hopefully you're all checking your inbox in Ivy Learn. That is where, when I send videos, that's where, or emails, that's where they're going to go, because that's the only spot I have in Ivy Learn. That's where I have a group list. So make sure you're logging into Ivy Learn periodically and checking your inbox, and I will be doing the same. So make sure we can communicate. Okay, back to my PowerPoint. So this week, yeah, make sure you check these out. Proctored exams, that's one thing I want to kind of talk about. You are expected to go to either an Ivy Tech campus or a different, I don't know, testing center 3 times for this class. And when you look at your calendar within Ivy Learn, you will see the deadlines for those exams. You can take those exams anytime before then, which means if you are super studious and you finish all of Unit 1 this weekend and you want to take the exam on Tuesday of next week, knock yourself out. I will be doing the proctor forms later today, so you'll be able to take all 3 exams as early as you want. If you really work hard and you finish the class on June 30th, then you're done on June 30th, and that's fantastic. I do not penalize you for finishing early. If you watched all the videos, you'll notice that the due dates set in the calendar are, I don't want to say optional, but they are recommended due dates. You have three hard due dates. Let me just 3 hard due dates, and those are the exam days. Everything from Unit 1 is due on June 24th. That's the last day you can submit the exam. So everything from Unit 1 is due that day, with the exception of the projects. The projects are kind of their own beast, and they have their own due dates. So Jessica, you have your hand raised. Do you have a question? If so, that's great. Feel free to unmute and talk, or you can type.
It shows on my computer I didn't have a hand raised, but did I?
Your hand is raised right now. Yeah, I can put it down.
Oh,
there you go. You're good.
Okay, thank you.
No problem.
Sorry about that.
You're good. You're good. We're going to check. I mean, this is going to be a learning process for everybody involved. So, you know, raising your hand, muting yourself. Yeah, we'll figure it out. So no worries, no worries. Okay, let's go ahead and move forward. Okay, no. There we go. So modules 1 and 2 is what we're going to do this week. Oh, I lied. That's 5 sections within the packet. Web work, you'll have 5 things to do. The orientation in web work is not for a grade. If you have used web work before, you can probably skip the orientation. If you haven't used it before, I would recommend taking the 10-15 minutes and doing it. Within web work, if you have a problem that you cannot figure out for the life of you, send me an email. So go into your email, type in bmenning@ivytech.edu and say, Becky, web work, homework 3, number 7, I'm stuck. And I will go in and look at the exact question you're working on, and I will give you feedback. Okay, so you have to ask. I will not go in and see where you're struggling, because I have 30 students in this class. But if you are struggling, I will help you, and pretty quickly. So just let me know. You're going to have a ton of discussion boards in this class, a ton of homework, and a ton of quizzes. Most of those things are not very long, and they shouldn't take you an enormous amount of time. Most quizzes have 5 questions or less. The web work number of problems, you probably look at homework 2 and about crapped your pants, because I think there are like 19 problems, but not all of them are that long, so don't fret. So as you have questions, please feel free to email me, call me, whatever, send a carrier pigeon, anything, so that I can help you out with things. So, okay, does anybody have any questions about how this course is working before I get into how I teach in this online session? Everybody feel pretty good with how things are going? Okay, I'm not going to tell you how to take this class because everybody needs different things from a math class. Everybody learns in a different way. So I'm just going to kind of tell you a couple things. In the past, I've had students who watch all of the videos for the sections that we're going to talk about before they come to this live session. That way they can ask questions and kind of use this as a refresher. Or I have people who come here first to get a basic view, and then they watch all the videos later so that they can do the homework and go from there. It doesn't matter to me how you do it. You can kind of do whatever you want. The benefit of watching videos and working on homework before you come is that you can ask questions and we can go from there. But again, it's whatever you want. This is your class and I want to tailor it to you. With that being said, we are only scheduled to spend 1 hour a week in a live format. I am willing to do optional live sessions on different days at different times. So if you are thinking, okay, we'll have this session on Wednesday and then, Thursday afternoon, you would like another one just for questions, fantastic. We can set those up pretty easily. As long as it doesn't cut into my golfing or softball playing, I'm pretty flexible. So you just guys kind of let me know a day and a time. And as long as there's nothing on my calendar, I can do this because I can do these sessions sitting at home in my pajamas on the couch or sitting at the beach, which is what I will be doing in the last week. So you just let me know what you guys need from me and I'll be willing to throw up a session and we can go from there. Okay? Have I lost anybody? Yes, no, no? Okay. Now, I did not go through the ins and outs of Ivy Learn because I sent you a video about that. So I do expect you to watch those videos to get the understanding of the class itself. That way we can just move on for the last 45 minutes today and actually talk about some math. So the rest of my PowerPoint, which I made this on Sunday, so it's going to be a surprise to all of us what comes next, is going to be kind of just the overarching high points of the first 4 or 5 sections. I think I only did the first 4 sections. So what you need to know, kind of the big picture. Obviously, the packet itself has way more examples, way more in depth, and you really should be working through that packet with the videos to make sure that you know what's going on. But that's kind of what you do on your own. So section 1, which does not have homework that goes with it. It's kind of your introductory section. And the big question is, what is quantitative reasoning? That is the title of the section. So, in my opinion, it's getting back on the math horse. Can anybody describe to me in their own words what is quantitative reasoning? So when you signed up for quantitative reasoning, what did that mean in your head? You can either type your answer, you can unmute yourself and start talking. Whatever you want to do. And Jessica, I just muted you because you were typing and it was loud. Ryan, I just muted you because you weren't muted, although you're inactive, so move your mouse. Okay. I don't like that I can't see when people are typing. That bothers me. But is anybody typing and giving me an answer, or do I just need to start talking? Oh, okay, so Jessica says graphs and probabilities. Those are both 2 big components in this class. Yes, we will talk about graphs throughout. There's 28 sections in this packet. I would say graphs are present in probably half of them in some respect, yes. Probabilities will come into play in a number of sections, primarily in Unit 2, but we will definitely talk about probabilities. Anybody else have something about quantitative reasoning they would like to share? Formulas? Yes. We will be using some formulas in different things. Scott says, thinking with numbers. Yes. And let's kind of go off of that. So when you kind of break down quantitative reasoning, the word quantitative is made up of quantity, right, or quantify. And so quantity means numbers. So quantitative simply means we are definitely playing with numbers. And then when you think about reasoning, well, reasoning means to think. So basically it breaks down to thinking with numbers. And so if you think about you're taking an entire class where you're going to think about numbers, it does go a little bit deeper than that. We will be playing with numbers. I say play because math is fun. So you're going to play with numbers. You're going to think about numbers. You're going to write an awful lot of meaningful sentences. And they might not mean anything to you, but they're going to mean something to me. So quantitative reasoning is thinking through the process. It's not just about doing the math. It's understanding what does it mean. So gone are the days where you're going to write down a bunch of numbers and circle the 4 at the end and then call the problem done. Now you're going to do all that math, and then after you get that 4, you're going to write me a sentence and tell me, what does that 4 mean? Why is it important? Where did it come from? So you got to think a little bit more than just rote repetition, if you will. All right, so that's basically section 1, is getting yourself reintroduced to the math portion. All right, section 2 is ratios. What can you tell me about ratios? And how can you write a ratio? All right, so Caitlin did a great job of giving us basically a real definition of ratios, which is a comparison between numbers. Yes, and then Ryan puts in a fraction, and good job. So a fraction is one way that we can write a ratio. Okay, so a ratio is, by definition, a comparison. And I'm going to apologize now for my handwriting because it's horrible in person. It's just as bad on a computer. So a ratio is a comparison. So using Ryan's example of as a fraction, so a ratio, right, we could write 3/4. That is one way to write a ratio. Now, by definition, the comparison piece, you can write it using a colon. You can write it as with the word 2, 3, 2, 4. Are there any other ways? Colon, fraction, per, thank you. Well, so 3 per 4. One thing about that is the word per generally refers to 1. So if we would do 3 divided by 4, think back to the fraction. If you divide 3 by 4, you end up with 0.75. So 0.75 over 1, this is the same thing, which would lead us to 0.75 per 1. Yes. Do decimals or percents work as well? Heck yes, they do. So you'll notice that we took that free 3/4 and changed it to a decimal, and that decimal then we could change to a percent. So yeah, all of these are kind of different ratios. A percent is out of 100, which we will spend time doing in, I think, probably next week. So that also is 75 over 100. So all of these different pieces are all equivalent ratios. If the question just asks for a ratio, any of these would be acceptable. Generally, and when I say generally, I don't know if this is my world or somebody else's world. And does anybody know how oh, pen color. There it is. I love different colors. All right, so fractions is generally the way I write ratios. And I'm going to tell you why. If you need to simplify problems or simplify a ratio, for me it's a whole lot easier to play with 3 over 4 than using the word 2, because my calculator will take that 3/4 and change it to a decimal. And then, excuse me, I know how to change a decimal to a percent. So by having it as a fraction, it allows me to do a whole lot of other things with it. And we are going to take these ratios and we're going to throw them into proportions here in about 10 minutes. And that's going to give us a whole nother world of mathematics to be in here. So again, you can write it however you want if the question asks for a ratio. But in order to make your life easier when you're playing with the math, it's probably easiest to write it as a fraction. Now, one thing about fractions, right, we are mathematicians. You are officially a mathematician because you are in my class and that's how we roll. If you are writing things as a fraction, they do need to be reduced. So 3/4 is a reduced fraction. But if we come over here to 75 over 100, that is not a reduced fraction. So make sure when you're submitting homework in an Excel document and you're putting it in IB Learn, or you're putting something in a discussion board, if you're using a fraction, make sure you do reduce that fraction. An easy way to get around that is just to change that to a decimal, and then you don't have to worry about reducing. But if you have questions on that, again, as you're working through things, feel free to shoot me an email, and I will get back to you on how to help with that. I've actually already answered one email today about reducing ugly fractions. So feel free, if you have questions or you want to just complain, you can do that too. All right, so that's a good one. So apparently I have to go to a non-drawing mode before I can switch to the next page, and I'm going to have to erase my drawings. Okay, fantastic. We're figuring this out. We're only 21 minutes in. Okay, so still in section 2, we have a lot of general ratios, and if you work through the packet, or when you work through the packet, you're going to do a lot of examples of different types of ratios. Now, the other thing that you need to be aware of is the age dependency ratios. These are specific types of ratios, and to be quite honest with you, I never really learned about dependency ratios until I started teaching this class, and now I find it fascinating. So these dependency ratios are used to discuss, economics. How is, and then I lose my words, how the economy is doing basically overall. Caitlin, packet referring to the book? Yes. I don't like to call it a book because to me a book has information in it, and this thing has a lot of, it's a workbook, right? You have a workbook. It's got blank spots for you to fill in. So I just have always referred to it as a packet. Just to make sure we're all talking about the same thing, let me get myself a little video. Where's it at? Come on, video. Oh, you can see me. Okay, so this screen, this right here, is the packet. So hopefully, if you have this, right, it's green. It probably doesn't say desk copy on it, but Math 123 with 080 materials. This is, when I say packet, this is what I'm referring to. So that's a good thing. While I'm talking about that, you will notice, I think it's page 246-ish. Oh, yeah, 245, 246. You have a yellow piece of paper. It's two-sided. This is your reference sheet. You don't need it much in Unit 1. Unit 2 and 3, you're going to need it a lot. This is what you should be given when you go to take your exam, Units 2 and 3. You don't need it for Unit 1. But when you go to take Unit 2 and 3 exams at the Ivy Tech, make sure they give you one of these. It probably won't be yellow, but they're important. Okay. Also, the back of the packet has 080 material, and that material is extra. So if you get, if you want more work on age dependency ratios, there are additional exercises in that 080 portion so that you can do that. And yes, if you have not received that, it should have come via mail. You should let me know. And if you signed up just in the last few days, it's probably still on its way. If you signed up over 2 weeks ago, you should have it by now. So we'll go from there. Okay, so these dependency ratios, I just want to talk about them a little bit because it seems that once you understand the dependency ratios, they go very well. Before that, they can be a little bit tricky. So children, right, we generally refer to children as 0 to 14. We talk about the 15 to 64 as the working class, and everybody 65 and over, we call them the old people, right, which I always love talking to my parents because I call them the old people based off of this. Okay, So when we talk about child dependency ratio, old age dependency, or the basic age dependency, everything is compared to the working class. Basically, it's thought about the working class are the people who are supporting everybody else, right? And if you just think kind of logically, if you, let's say that you were one of four, I was one of four kids, both of my parents worked. So they were the working class, my parents, because they worked and they supported the four kids who, sucked their money dry. So a child dependency ratio, just think what that means. We're talking about children. So we are comparing the children compared to the workers. Okay, so how many children do we have in this example? Well, we have 400. So total of 400 children over the working class, which would be 850. All right, now, your job right now is to change that fraction to a decimal. Okay, so 0.470 is what Myra says. Does everybody agree with that? I hope so, because I didn't do the math. That's why I have you guys. All right, so when you're talking about child dependency ratios, 0.47, now, okay. All right, so when you can make this a fraction by putting it over 1. Now, what that means, because you are going to need to understand what these ratios mean, I'm going to write down here. That means we have 0.470 children dependent, right, we're talking about dependency ratios, dependent on each worker. And that sounds a little bit weird because how is a worker supporting 0.7 of a child, right? So if that bothers you because you don't think people can be fractions, well, you haven't met my coworkers. But if you move, right, decimals 2 places, you can do anything as long as you're consistent. So if I want to move this decimal 2 places to make this a 47, well, in my denominator, I can move it 2 places, and that makes that 100. So that means 47 children are dependent on 100 workers. So those two sentences have the same meaning, right? We just changed the ratio to make it something that's a little bit easier to understand. All right, stop me if you have questions, and if you don't, I'll just keep talking. All right, so talking about old age dependency, again, you let your common sense help you. We're talking about old people. Well, if you look at our table, we have 220 old people, and we always compare dependency ratios to the working class. So that's where the 850 comes from. All right, we don't like fractions that are big. One, you got to reduce it. Nobody wants to reduce that fraction. So let's go ahead and change that fraction to a decimal. What is 220 over 850 as a decimal? Go to 3 decimal places. All right, so if it's 0.2, this is a good little side discussion. If it's 0.2588, as Myra just put there in there, if we want to go to, let's go red. If I want to go to the 3rd decimal place, I look 1 place past to round. Does 8 tell me to round up or down? Up is correct. Good. I'm glad to see a ton of you saying that. Makes my heart happy. So we're at 0.259. So again, you can compare that to 1, or you can move the decimal to say there are 259 old people dependent on every 1,000 workers. So you can change that to make it work. All right, I hope I'm not losing anybody. All right, so let me get myself a little spot here to do my age dependency. Now, when we go to just straight age, and we're not differentiating between old and young, age says we want everybody who's dependent compared to the working class. So I take my little chitlins, and I add the old fogies, and I compare both of them to the working class of 850. So my numerator of 400 plus 220 gives me And there's not very many color options here. So we end up with 620 divided by 850. One more time, what is that as a decimal to 3 decimal places, please? Excellent, 0.729. Good work, good work. All right, so that's age dependency ratios. And I would say usually in section 2, this is the part that trips people up because it's new, right? At some point in your life, and however many years you've been alive, you have dealt with ratios in some respect. But age dependency ratios are a little bit different and a little bit more specific, and it makes it a little bit more, you know, your brain's got to work a little more. So those, I think, are the last 2 problems in section 2. If you get stuck, shoot me an email. It's probably a rounding issue, and I will help you. All right, so that's section 2. We are moving right along. I probably should have come up with more problems. All right, so let's... there. Scientific notation, section 3. I'm going to click a button to see if this works. I believe I have now given you all access to write. I don't know if it's true or not, but oh, damn it. Okay. I would like somebody to tell me about scientific notation. I mean, I've got a few just random things here, but what can you tell me about scientific notation? And you can write on the board if you can figure out how to do it, or you can talk verbally, or you can type in the chat box. All right, so Eric says it's a shorthand way of writing large numbers. That is a true statement. Don't use a question mark. Be confident in your answer. Even if you're wrong, be confident. Because let me tell you, people believe what you say if you're confident. You don't even have to be right. How do you think I teach every day? Okay, so goes to a power such as 10 times 8 to the 9th. That is almost correct. Oh, Eric, exclamation point. Excellent. Number and size. Yes, it definitely deals with this big and small, I have small there, of numbers. So we call it scientific notation because usually it's scientists who use this crap because they're the ones who are dealing with super big numbers like the distance between the Earth and the Sun, or super small numbers like, I don't know, the diameter of skin cells. Crap like that, you know, most of us don't care about. So how do we write this? Now, Ryan was almost right. He was missing one key piece when he did his. Okay, let me go here. When we're talking about this, we're going to have a number, and we're going to have it times 10 to another number, right? So I've got 2 openings here. And it's kind of important that we recognize this. The first number here must be between, oops, I forgot my 1, between 1 and 10. All right, so you can't have 0.6 because that is less than 1, and you can't have 10.2 because that's larger than 10. So you want to have a single number in front of the decimal point, and then this number up here can be positive or negative, right? Positive means we have a big number. Negative means we have a small number. Now, when I say big, big means larger than 10. And when I say small, that means less than 1. So 1 and 10 are your references. Okay, big is greater than 10, small is less than 1. So I want to just show you a couple, how do you write scientific notation? Like 3.8, oops, oh, okay, 3.8 times 10 to the 4th. That is scientific notation. This would be considered a large number because notice how my exponent is positive. Or I could have 1.23 times 10 to the negative 5th, This is a super small number because my exponent is negative. The exponent tells you how to move the decimal, how many places to move the decimal when we are moving between scientific notation and standard form. Okay, so that's kind of your intro. Now we're actually going to play with it. So let's go ahead and erase those, move to the next page. There we go. Whew. So it will be important that you can move between these two. So you're going to have problems in web work that are going to say, write your answer in scientific notation or write your answer in standard form. So you've got to be able to go both ways. Depending on your calculator, some calculators, when you have big math that you're doing, they will give you the answer in scientific notation. So if you type some crap into your calculator and it spits out a number and you don't know what it means, feel free to take a picture with your smartphone and email me the picture, and I can tell you what it means, because I've seen most calculators. So don't freak out if you think your calculator's broken. It's probably just writing it in a different way you're not used to. Okay, so this first one, convert 320,000 to scientific notation. You should probably know that I'm lazy, so I will use a lot of shorthand when I create things. So SN is scientific notation. So first things first, 320,000, we would consider that to be a large number. It's large because it's bigger than 10. We want the first number to be between 1 and 10. So where am I going to put my decimal point so that the first number is between 1 and 10? The decimal point should go after the what? 3. Thank you. So we're going to put the decimal point here. Now it's important that all non-zero numbers are included. So your first number is going to be 3.2 because those are all of the non-zero numbers in here. Okay, so 3.2 times 10. And then when you're figuring out your beautiful exponent, well, the decimal point started here. Remember in math, if you don't see it, it's automatically at the end. So how many spots did we move to go from green to pink? Well, 1, 2, 3, 4, 5. So basically, if you can count, that will help. If you can't, use your toes. So we have 3.2 times 10 to the 5th, and there's my answer in scientific notation. We know our exponent is going to be a positive 5 because 320,000 was a large number. All right, let's go to the second one. Now we're going to go to standard form. So we have ourselves 1.75 times 10 to the 4th. The 4 is positive. Positive tells you have a big number. If I have a big number, which way am I going to move my decimal point? Right or left to make my number bigger? To the right. Yes. So if you want your number to get bigger, the decimal goes to the right. So if I have 1.75 and then I want to go right 4 places, 1, 2, 3, 4, in these empty humps we have zeros. So I end up with 17,500. Again, big number makes sense because my exponent was positive. All right, so I think, wait, okay, what do I got to do? Erase drawings. There we go. All right, so that's section 3, scientific notation. Look at us on to section 4, rocking this out. Okay. And again, if I lose anybody as we're going or you have questions, you just go ahead and either raise your hand or type a question, interrupt with words, whatever makes you happy. Okay, so section 4, we're getting into per capita. Now, per capita is another application of ratios. So, when we talk about, I need my calculator, pen, color, orange. The word per is going to be your best friend, and if it's not now, you need to just open your heart and let it in. So the word per means what? Each, yeah. Scott's cheating, he's got his book open. So each implies 1. So anytime you see the word per, you're seeing per, you should think of the word 1 or each, yeah, just for 1. Okay, so this is definition of per 1, okay, capita. What does the word capita stand for? You can have your book open. It's okay. What does capita stand for? And you're going to see this a lot throughout this class. We're going to talk about per capita like 4 different times. Ryan, you should know this one. Person, very good. All right, so when we're talking about capita, we're talking about people. Caitlin, that's a very good point. It's not cheating, it's using your resources. I love it. I use that a lot. Love it. All right, and I think it's fantastic if people have their books open while we're in class. That's important. Okay, so per capita means per person. So when you're talking about anything per capita, per is also going to tell you kind of a division bar. So when we're talking about something per capita, you're going to put whatever it is you're talking about. So I'm just going to call it something. Something, per implies the fraction bar, and then the people are going to go on the bottom. So it's just very, very important that you put the people on the bottom. All right, so let's look at our second example here. Well, actually, it's our first example of this one, but whatever. If there are 240 TVs in my family and 78 family members, how many TVs per capita? And this is probably pretty accurate. Okay, so if we're talking about TVs per capita, remember the word per implies the fraction, and we're talking about per one person. So in words, we're talking about TVs, per is the fraction bar, and we're going to put people on the bottom. So if you're confused, at least for a while, on how things work, instead of just going straight to numbers, do things in terms of words. Because if you understand how the words go together, the numbers are easy because you just plug them in where they're represented by words. So make sure you're thinking through what these numbers mean. Okay, so if I know TVs per capita, TVs on the top, people on the bottom. Now let's go to numbers. How many TVs do I have in this family? 240. Okay, so 240 is my numerator. How many people are in this family? 78. Great. Does that answer the question of per capita? That was a yes/no question. No. Thank you. So per capita implies per one. This, our pink fraction here, it's a great ratio. It's beautiful. Well, it's not reduced, but whatever. But it's per 78. So I need to change this pink fraction into a per one. So we're going to take our 240 divided by 78 in your calculator. And according to Martha, we end up with 0.0. I think you're considered one of the 78. At least when I typed the question, that was my thought process. In my family, we have 78 total family members. That's when you want to definitely show your work. Because if you show your work, then I can give you partial credit. Okay, so 3 point something. Where's the long fraction? 3.0769 blah, 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 blah. And so Mercedes said, let's go ahead and round, which I always appreciate a good round job. So if you round up, 6 rounds up, we end up with 3.08 TVs per person. Whoop, TVs per person. Yep, there's your bad handwriting for you today. So, and I write this because 3.08 is the correct answer. Great, you could even round to 3 if you really want to get, specific. But then you're going to want to make sure you understand what does that mean, right? There's TVs per person. So every person in my family has roughly 3 TVs. That's actually probably pretty accurate. All right, so that's per capita. It doesn't matter what you're talking about, but the crap goes on top and the people go on the bottom. All right? Any other questions about per capita? Gone once, gone twice. Okay, While we're in section 4, we come back to scientific notation, but you'll notice now we're dealing with the small numbers. So small numbers because it's less than 1, and a small number because it's got a negative exponent. I'm going to give you guys about a minute. I would like you to do both problems you see here on this page dealing with per capita. All right, we got a lot of answers coming in. So in the first one, just to kind of recall, you want that decimal point to be moved between the two numbers. So you want the first, I don't know how to talk, you want one number in front of the decimal. That's your goal, right? 2.3 is between 1 and 10. So we moved that 1, 2, 3, 4, 5, 6 places to get there, and because it's a small number, we need a negative exponent. So don't forget your negative exponent. So we do have, some of you have incorrect exponents or incorrect beginning numbers. Make sure your first number should always be between 1 and 10. So this number here, only one number in front of the decimal. And then when you're going to, I'm a big fan, I'm a seer, I got to see to believe. So when I, between my 2 and 3, how many spots did I move to get there? And it's okay to put the humps in there to count, right? So you moved it 6 places, so your exponent has to be a 6. When I try to eyeball things, I always end up counting 1 too few or 1 too many, and it's never a good thing. So hashtag details matter in this class, like whoa. All right. In the second one, our exponent is -3. The negative tells us our number needs to get smaller, which means we're going to move our decimal to the left because that will make it smaller, and we're going to move it 3 places. So right now I have a number of 9.3, and I'm going to move that to the left, as we just said, 3 places, 1, 2, 3. So now this is where my new decimal point lies. Left 3 places. I've got 2 empty humps, so that's where my zeros go. So as many of you have stated in the chat box, we're at 0.0093. And you will have plenty of practice with scientific notation going both directions within web work, sections 3 and 4. And we are going to do more playing with scientific notation in the later sections. So it's never going to go away. We're going to be using this throughout the entire 8 weeks, all 28 sections. So make sure you understand what's going on now, or it's going to make everything just a little bit trickier. So if you have questions while you're working through these, let me know. All right, so let's move now. I did put section 5 in here. Look at that. All right, so we're down to 11 minutes, which is perfect. So we have one section left. Section 5 is one of my favorites because I love proportions. Why do you say? Did you all just ask why? That's what I heard. I love proportions. I think they're fab. So a proportion, if you want to go by definition, is basically 2 ratios being set equal to each other. We know what a ratio is. We talked about it 20 minutes ago, right? It's fresh in your head. So a ratio is comparing 2 numbers. So if you have fractions, right, you have 2 fractions set equal to each other, therefore you have a proportion. Now, you will notice in this lovely proportion we have our best friend, x, and we need to find x. So the goal of our proportion here is just to find the value of x. Do any of you remember from your past mathematical days how to solve a basic proportion? Cross multiply. Exactly. So that means we're going to take the bottom of one fraction and multiply the top of the other. This only works because we have an equal sign between them. So I'm going to take 12 times 2, and I'm going to set that equal to the other direction, 3 times x. All right. So just to make sure that we are all on board with all of our steps, because it's important, the equal sign breaks your equation up into two equal sides, hence the equal sign. First, we're going to take 12 times 2. What is 12 times 2? 24. Excellent. So 24 equals 3x. A number touching a variable implies multiplication. How do I undo multiplication? You divide. So we will divide both sides by the number in front of the variable, because 3 divided by 3 ends up being 1, so we end up with 1x, and then 24 divided by 3 is 8, just like y'all said earlier. All right, so that's the basic how to solve a proportion. Now that's super great, and if that's all we were doing with them, wow, wouldn't life be magical? Unfortunately for you, that is not all we are doing with them, so you can just get over it. We are going to be spending most of our time with story problems. I know, you love it, I can tell already. So we have ourselves, Sally ran 4 miles to every 3 miles run by Billy. Billy needs to pick it up. If Billy ran 254 miles in 2016, how many miles did Sally run? Now, some of you can say, oh, I get it, and you can pick up your calculator and you can type things in and miraculously you have the right answer. Fantastic. Some of you look at this and go, there are words and that sucks. And I agree, because math should have numbers and no words. But alas, it is what it is. So I highly recommend that you figure out how to organize your work in words, because if you understand what it looks like using words, the numbers, again, I said this earlier, will just come easily. So we are talking about two people in this problem. We are talking about our friend Sally and our motivated friend Billy. I shouldn't say unmotivated. He's running more than I am. All right, so I'm going to set it up that every time we talk about Sally, I'm going to put her in the numerator. And every time I talk about Billy, I'm going to put him in the denominator, right? And it doesn't matter it doesn't matter as long as your numbers follow your people. So in my first statement, Sally ran 4 miles to every 3 miles run by Billy. I can write a fraction with that, right? Because Sally's on the top, 4 miles, for every 3 miles run by Billy. So that's a ratio, right? 4 to 3, Sally to Billy. Okay, well, if they stay in proportion with their running, which maybe they did, maybe they didn't, then it says Billy ran 254 miles. Is that going to go on the top or the bottom? Based off people's answers, on the bottom, because it's Billy, and we're trying to find out how many miles that Sally ran. So the majority of the time when we're playing with proportions, you're going to have to set it up first before you can solve it. The solving is the easy part. The setting it up is what sometimes tricks people. And that's, if you are a visual person, you might want to get your words off to the left so that you can see exactly what goes where. So does anybody have an answer for this? How many miles did poor Sally run? Okay. So if you cross multiply 3x equals 4 times 254, you do end up, if you round to the nearest tenth, 338.7 miles. When you are doing story problems, it is going to be crucial that you label your answer. So make sure, if you just say 338.7, I might think you're talking about the number of dollars you're going to pay me, you know, to not do a homework assignment, which, you know, call me. We could talk. So that's kind of where we're at, right? So you got to set it up and then you can solve it. Questions on Sally and Billy and their running? Anyone? Anyone? Bueller? Okay. All right. I think this might be the last page, which I hope it is because we're down to 5 minutes. The thing with proportions that screws people up the most is what I call the what if game. So there are a lot of times that we have information, but then we say, well, what if things were a little bit different? How would that change? So we're going to play one what if game. So Michigan, I don't know, I just made up these numbers. Michigan raised $16,500 with 250 people. And Ohio, because they're better, raised $24,750 with 300 people. Okay, so that's data. We know that. We have both of those information, the dollar amounts and the number of people for both states. But then the question says, if Michigan were proportional to Ohio, so if Michigan were as good as Ohio, how much money would Michigan have raised? So what did I just do? It's always the question. There we go. Okay, so notice how it says how much money would Michigan have raised. So we don't care about the 16,500. That's what they actually did. We want to say, what if they were like Ohio? Let's find that out. So we're going to replace that with X and say, okay, let's compare Michigan and Ohio. We're trying to figure out how much would Michigan have raised compared to Ohio's 24,750 if they had 250 people and Ohio had 300. So the number of people stays the same, right? We can't just knock off people. That's bad. You should not do that. So we're going to keep the same number of people, but how much money would they have raised if they were like Ohio? Okay, so let's cross multiply that. Good, Martha. So we have 20,625. So if Michigan was like Ohio, they would have raised $20,625. Instead, they're not, so they're a little under 4,000 compared to that. Okay, so you can do the what if game. That's the purpose, all right? And yeah, so you could, Michigan needs, good. Way to kind of put that in a sentence. That was good. That was good. All right, so proportions. Sometimes they just give us information. Eric, is it important to keep the people over people and money over money? Not entirely. You can write every proportion 4 ways. So you could have put Michigan over Michigan and Ohio over Ohio. The important thing, when I say be consistent, in this problem, all the money is on top and all the people are on the bottom, and this first one is Michigan and the second one is Ohio. So as long as you're staying consistent, you can flip-flop them a little bit. You have 4 possible correct ways to set up every proportion. The key is when you cross-multiply, so if we set up all 4 different ways, when we cross-multiply, we would still have the same problem. So that's kind of the key. Yeah. Other questions on proportions, per capita, ratios, scientific notation, or anything else in general? Okay. So this is generally how class is going to roll. We'll talk about what's expected for the week, what homework assignments you have, what's coming up, all that kind of fun stuff. And then we will go through the highlights of whatever sections are for that week. So next week, I believe we will do sections 6 through 9. And that will allow us to kind of, which is the second half of Unit 1. So just prepare yourself for that. You should be working through the videos that go with the packet so that you can have more practice with the different types of problems. And then you can get into your web work. After you do your web work, I would recommend doing the quizzes. Your discussion boards, I would always recommend doing discussion boards after our session. So some of them are going to say, reflect on what you did in the session today. You can't really do that on a Monday if you haven't watched the session yet. So for the people who aren't here, right, I said the class had 30 people in it, 17 are here live. I am going to figure out how to, I recorded this, luckily I did not forget. I will have the link and I will be posting the link, and I don't know where, but it'll be around somewhere. Make sure you are, what's the word I'm looking for? I don't know. You don't know either. Checking your announcements. I will be posting everything in announcements because I think people will see those. So make sure you're checking those periodically. Check your inbox within IB Learn, because if I send messages, that's where they go. So yeah, keep checking things out. Let me know if you have questions. Check out your calendar. If you haven't already done that, check it out. Everything, I believe, red is the quantitative reasoning class in my calendar. So you can see, I would expect, like by tomorrow, you should be able to do discussion board number 1 by tomorrow, because it's a reflection, I think, pretty much on today's session. So if you were here live, you could do it right now. Nothing too exciting about that. But get through, try to keep up with this due date schedule, because if you can, your life's going to be a whole lot easier. You'll see that the 24th is exam 1. That's the last day possible, and you'll notice that is a Saturday. If you are planning on taking your exam at the Warsaw campus, I don't think we're open on Saturdays in the summer. So don't wait until Saturday and hope you can walk in, because that's not going to work. And guess what happens when you email me on Saturday and say, I didn't take my exam this week? I'm going to say, tough shit, looks like you get a 0. So make sure you're planning ahead, because I am very unsympathetic to people who wait till the last minute and then expect me to show them pity. Okay, so plan ahead, figure out where you're taking your exams, and then once you get the Unit 1 material done, you can take your exam and your life will be awesome. But probably not until then. Okay, any other questions for me? It is 2:02, which means class is officially over 2 minutes ago. So if you have questions, I will stick around for as long as people have questions. Feel free to talk, feel free to type. If you're done, sign off, go live in peace, and I will see you next Wednesday at 1 o'clock. Email me with questions. Okay, bye.